My name is Precious Parker.
I'm Shivara Zada.
And I'm Yasmin Erickson.
Today we'll be talking about glacial recession and how it affects the mountain.
So basically, a glacier is a compact layer of ice after a lot of snowfall occurs. And it is also, it's not just ice, but it moves, it flows. And so yeah, that's what makes a glacier. And there's 3 different zones on that glacier.
The first zone, which is the upper part of the mountain, it's called the accumulation zone, and that's where it mainly snows and less melts. And then there's the transition zone where it gets the same amount of snow that melts that year, so basically no difference in the end. And then there's the ablation zone, which is a fancy word for basically melting and other forms of that.
Losing mass in any way.
So, one of our experiments was me going into a crevasse and studying the density, and so as you can see in that picture over there, you can see the brown marks that Cece was talking about, the brown lines, and those show the dust that wind carried or that was mixed into snow, and it's usually yearly. And then you can see some thin lines, which are just from windstorms. And so I went down approximately 15 feet, and we did this hardness test by doing a fist punch and 4 fingers, 1 finger, a pencil, or a knife. And at 15 feet, nothing would go in besides the knife. So by that, we could tell that it was frozen, and then at 12 meters, there was a pencil. The pencil would only go in, and that means that it was frozen. It was super close to becoming the ice. And then at 9 meters, 1 finger, 6 meters, 4 fingers, and as well at 3 meters.
So next we have the transition zone. The transition zone is where there's melting and a creation of ice on the mountain. Yearly there's an equilibrium of, like she said, melting and ice creation. Here we conducted a research. First we drilled 22 centimeter holes into exposed ice, and then 22 holes into insulated glacier ice. The first one was 20 centimeters, covered by 20 centimeters of snow, and the second one was covered by 50 centimeters of snow. Over the course of 3 days, the exposed glacier ice melted more than the 22 centimeters. The first hole, which was covered by 20 centimeters of snow, had melted, leaving only 1 centimeter of glacier ice exposed. And the second one, which had 50 centimeters of snow covered, left only 5 centimeters of glacier ice exposed. We can conclude that snow is an insulating blanket for glacier ice. It delays the process of melting and keeps the glacier ice preserved longer. As you see, over the summer, there's more snow melt and exposed ice, and that causes the increase in melting of the ice.
So the ablation zone is basically the bottom of the glacier. So at the terminus, it's just the edge of the glacier. And this is where the most melting occurs, and usually there's much more melting than there is snowfall. And this is where you'll usually see a receding of the glacier is in the ablation zone. So what we did was we walked along the edge of the terminus, which is the edge of the glacier, and we got like mapping locations on a GPS device to map the edge. And then we compared these mapping locations, which in the blue line represents like what we did this year, to previous Girls on Ice members who had mapped the edge earlier, and we discovered that the glacier has indeed receded, as you can see, because the blue line is the most thin around the edge of the terminus, And there are two different types of pictures, two from 1994 and two from 2011. And if you see in the 1994 images, the glacier is a lot wider and there's longer terminus. So there is definitely, the glacier has receded quite a bit. And that's what we discovered. And we can also infer that there's a correlation between increased temperatures over annually, average temperatures over the last 15 years. It looks like a little, only 0.5 degrees Celsius, but that's actually quite a bit over time that this average has been increasing. And a lot of it can be due to just different amounts of precipitation each year, but it's also due to just like warming, the earth warming. And so that, we believe, could connect to the glacier receding.
So in conclusion, the deeper you go in a crevasse, the more dense the snow gets because there is less air in the compressed snow, which makes it harder, and then that leads to the glacier flowing down.
It flows down a transition zone where you see some melting and some creation of more glacier ice.
And then in the ablation zone, this ice melts. And what has happened is that there's more melting than there is accumulation of snow in the past years, and that's why this glacier, the Easton Glacier, as well as other glaciers, have been receding over the years and actually getting